Welcome to Summarize Science, where we break down the latest research. Today, we're looking at a fascinating new paper called EvoCAD, which introduces a novel way for AI to generate 3D models for computer-aided design, or CAD. The goal is to let anyone create a complex 3D object simply by describing it in plain English. The process shown here is inspired by biological evolution. First, a user provides a text prompt, like a rectangular block with a hole through the middle. The AI doesn't just create one version, it generates an entire initial population of different code attempts to create that object. This is like the brainstorming phase, creating a diverse set of initial ideas. From there, the system begins a process of evolutionary optimization to refine these ideas over several generations. So how does this evolution actually work? The system uses a vision AI to look at all the generated 3D objects and a reasoning AI to rank how well they match the original prompt. The highest-ranking objects are considered the fittest and are selected to breed. The AI then intelligently combines the code from two parent designs and sometimes adds random mutations to create a new and hopefully improved offspring design. A major contribution of this work is how they measure success. Instead of just looking at the object's surface, the researchers introduced new metrics that check the object's topology. In simple terms, it's a way for the AI to understand and count fundamental features, like the number of holes an object has, which is critical for engineering parts. And these charts show that the method really works. The graph on the left shows that with each new generation, the percentage of topologically correct objects increases significantly. Meanwhile, the graph on the right shows the average error, or wrongness, decreases. This proves the system is effectively learning and improving over time, homing in on the correct design. But the most impressive results are the visual ones. Here, you can see EvoCAD's final results compared to the ground truth and two previous methods. In the very first row, the prompt asks for a page with two holes, like from a hole puncher. EvoCAD gets it perfectly right, while the other methods create solid blocks with no holes. You can see this pattern again and again. For example, in the third row, only EvoCAD correctly creates the square-shaped hole going through the object. This demonstrates a much deeper, structural understanding of the request. So let's recap the key points. By combining large language models with the principles of evolution, this system can generate highly accurate 3D models from text. It gets better with each generation and uses a clever method to verify the object's core structure, like its number of holes, not just its surface shape. This research could dramatically speed up design and manufacturing, allowing engineers to create and test new parts almost as fast as they can think of them. A future where you can simply talk your ideas into existence is getting closer every day.